Assalamualaikum and greetings to all. Welcome back. We are still on domain and range, but now we're going to proceed with function with three variables. Okay, let's move on to the example. So the first one is here we have a function x, y, ln z. So I'm going to write that as w equals a function of x, y, z equals x, y, ln x. So now the domain, hang on. The domain would be set of points as well, but now our point consists of x, y, and z. Okay, so before with two variables, our points consist of x coordinate and y coordinate, but now our point consists of x coordinate, y coordinate, and z coordinate. Alright, so now we have to ask ourselves, is there any restriction on x, y, and z so that the function is defined? Okay, let's see. Here we have x occur here. Okay, so x is multiplied with y and ln z. So I don't think there is any restriction for x. You can multiply any real value. So x can be any real value. What about y? Y occur here. Okay, again, y is multiplied to x and ln z. So no restriction for y. Y can be any real value. But then we look at z. Z here is inside the ln function. And as you know, for ln, the value inside the ln function must be larger than 0. Otherwise, it's not defined. You cannot find ln of a negative value. So there is restriction for z. Z must be larger than 0. So that would be the domain of our function. So if you want to sketch this, it's going to be hard. So for a space, we have z-axis, x-axis, y-axis. Alright, so, that's a y. This is y-axis, this is x-axis, and z-axis. And here we have the negative y, and here we have the negative x, and here we have the negative z. So all in all, we have 8. We call it octants. So we have 8 sections here. Above the xy plane, so here we have the xy plane. Above the xy plane, we have 4 sections, and below the xy plane, we have another 4 sections. So 4 plus 4 is 8. So we have 8. So before in 2D, we call it first quadrant, second quadrant, third, and fourth. But for XYZ space, we have octant. First octant, stands for 8. So first octant, second octant, and so on. Alright, so for first, second, third, and fourth octant, they are above the XY plane. 5 till 8 would be below the XY plane. So for our domain, x real number, y real number, but then here we have z larger than 0, which means that our points must be above the xy plane. Okay, it doesn't include the xy plane, because on the xy plane, the z coordinates are 0. So it has to be all the points above the xy plane. So the domain of the function contains all the points above the xy plane. Okay, so that would be, if you want to sketch this, it will be all the points in the first, second, third, and fourth octant without the points on the xy plane. Alright, so that is example 1. Okay, now we can proceed to example 2. Okay, in example 2, we have w is equal to 1 over x squared plus y squared plus z squared. Okay, alright, so here you have to be careful because we have a rational function. We have 1 in the numerator, and then we have x squared plus y squared plus z squared in the denominator. Okay, so for rational function, there is a constraint. The constraint is the denominator cannot be 0. So for our function here, the denominator is this expression, x squared plus y squared plus z squared. yeah, x squared plus y squared plus z squared. So the denominator cannot be 0, otherwise the function is not defined. So that would be our domain. Okay, but before we can write this, we can simplify this even further. The only way for x squared plus y squared plus z squared to be 0 is for all of them to be 0. Okay, so here x squared plus x squared is always positive. The least possible value is 0. For y squared, it is also positive, always positive, because we square it. The least possible value is 0. That is when y is 0. And here, z squared is also always positive. The least possible value for z squared is 0. That happens when z is 0. So the only way for x squared plus y squared plus z squared to be 0 is at the origin. Okay, is at the origin. At other point, it won't be 0. And it won't be negative either. It will be positive, larger than 0. So the domain, again, the domain would be set of points. Oops, that's ugly. Hang on. All right. X, Y, Z. So it's going to be set of points. You can write it down as this, not 0. But we can write this in a much more professional manner. We just say that all points except the origin. So we can write it down as x, y, z is not the origin. So other than the origin, it will be the domain of the function. So that's the domain. Okay, and how are we doing with time? Okay, I can carry on a bit further. It doesn't ask for range, but we can find for range as well. For range, we look for f, or we can use w. I'm going to use w, or you can use f if you like. Alright, so here we have w, or f, is equal to 1 over x squared plus y squared plus z squared. As you can see here, w cannot be negative, because for w to be negative, you have to have 1, which is a positive value, divided by a negative value in the numerator. But in the numerator, which is the denominator, which is x squared plus y squared plus z squared, is always positive, and it cannot be 0, because if it's 0, then it's not in the domain. So in this case, w is always positive. Okay, 1 divided by the denominator, which is positive, and it cannot be negative, and it cannot be 0, because for w to be 0, the numerator must be 0, but here the numerator is 1. Okay, so you can say that w is larger than 0. It's always positive. Okay, so that's the range. Oh, you might ask for example 1. What is the range for example 1? Okay, forgot about that. Okay, for range, let me write it here. For example 1, the range would be all possible value of w. Okay, so for w here, it's x times y times ln z. So x and y here can be any real number, so it can be positive or negative, it can be 0. And for ln z here, it can be for ln z must be positive, but ln z, when z is less between 0 and 1, it will be negative. So x, y, and ln z, they can be positive, negative, and 0. So in this case, w can be any real number. Okay. Alright, so that's the range for example 1. Okay, that's it for this video. Thank you.